Right, so today I was experimenting with some inserts which I made for the generator. I 3D printed these little plastic sleeves. I pushed the coil down and to compress the coil further down, and as a result I actually lost about 50 RPM because the coupling is closer but it's tighter. And then I realised after I'd done this the reason why it's less efficient and why it's actually lost 50 RPM, even though the output current's the same, the coupling's closer. My input current went up by about 20 milliamps. My output current is the same and the waveform is the same, so the actual RMS is the same, but that's because of the two LEDs which were connected across it. So what I came to the conclusion, and after thinking about it, I realised what the issue is, and that is that the coils need to be of a wider footprint, slightly wider footprint, to maintain coupling to the rotor anti-drag segments. Let me just take this off. Maybe it's easy to see if I just take that off, I suppose. Right, I'll take this other canopy off because it's just blocking the view. So I've actually started to wind another coil on here. I recycled some of the wire, took off one of my old canopies. Right, so to try and explain it, I'm getting old. Right, so the segments, when the coil is over a wider area, the coil has a longer period to interact with the anti-drag or drag cancellation of the segment magnets, right? Which makes perfect sense because as the field, the main field, which is the center and these two sections, when the field has passed the coil, we need to maintain interaction with the anti-drag segments for a longer period of time, because once the field collapses from the generator magnets, which are here, here and here, once that field is collapsing, we only have a few milliseconds or microseconds where we can apply anti-drag from the capacitance that's stored in the output capacitors which is across the AC coil. Now what's interesting is when I load the coil with the capacitance, which is about 49 microfarad, because there's 1 microfarad metal film capacitors and there's 147 microfarad electrolytic. It's an non-polar, by the way, it's a non-polar electrolytic. So when that power is stored, when I actually put that across the coil, it doesn't slow down at all, right? You would think, oh, hang on, if you're putting a coil across an AC signal, AC output, you would expect it to cause drag, but it doesn't, because it's charging the capacitor up, and when that capacitor is fully charged and these poles, this polarity of these magnets is actually left the coil, when it's gone past the coil, it's going in this direction actually. So when it's past the coil, the anti-drag magnets are actually reacting to that coil, and the capacitance that's stored in the electrolytics and the capacitors is pushing the coil forwards instead of dragging it backwards, right? So that's why we don't see a slowdown. But if we apply a load, that energy from the generator part is immediately used up straight away, right? So if you use all that power straight away, there's nothing left, no capacitance left stored anywhere. to react through the coil with the anti-drag magnets. So you see then we see a slowdown. So what we have to do is have a happy medium where there's power left in the capacitors, and this is the reason why I'm using the delay choke. The delay line, the choke here, which I wound previously for another job which I'm using now, the way the choke works is it stores energy, so that the energy goes in, and we have a high impedance on the first rise time, and the impedance of the choke increases. Sorry, the impedance of the choke decreases once it becomes saturated with voltage or current. And the capacitor is directly across the output of the coil of the generator. So the capacitance is storing the energy that is creating our anti-drag situation, and that power is slowly going through the choke. Now, so the capacitor does the job of cancelling the drag on the rotor assembly, and then the power is released from the choke a few microseconds later to light the LEDs. So this is why we don't see much drag on the system. However, sorry, I'm kneeling down right now, and it's a bit awkward. So that is the reason why we don't see a lot of drag when I put the LEDs on it. So the conclusion I came to was that we need to increase the width of the coil, because if I widen the field of the coil so it's slightly wider, wound a bit wider, that gives the coil a longer period of time in microseconds to react to the anti-drag part of the circuit, which is on the segments. So that's what I need to do, and I've actually made changes to my SketchUp model on the canopy, so that when I wind the next coils, they'll have a wider footprint, and they'll actually produce more power though. But because of the wider footprint, that gives me more window for the coil to both charge the capacitors and to continue on the anti-drag circuit and to create acceleration, and that's what we should see, is more acceleration, more RPM I should say, instead of less RPM, because as I said, I've already found out that by compressing the coils I lost 50 RPM. So we should, and that is similar to narrowing the actual area, the magnetic field area that the coil is interacting with. It's a similar thing, but I don't want to widen it too much because we have to maintain that window, and all of the window field is really from here to here. It's a large window, but some of the coil in the center here, this section right in the middle, is not, there's no coil there, right? And we have a strong field right in the middle, so I'm not actually taking advantage of the field right in the center of the segment, right? Because there's no coil there. So what I want to do is wind another coil, but bring it so that it's more inwards towards the main field in the center. But I also want to move it slightly further out so that it's further this way as well, so we have a wider window footprint basically. So I wanted to explain that because it's a bit difficult to understand it, but I've been doing a lot of thinking about it. Now originally what I did do was I did wind some coils, very narrow coils, and they didn't work so well, but that was before I had the magnets in the middle. I don't know if I've got them still. No, I've taken the wire off that canopy actually, but let me just check. Hang on a minute. See if I can find one. Sorry, my wire, I can't see it. Yeah, I've taken the wire off it. I wrapped it onto this other spool, so there's a full coil on this spool which I've I'm going to recycle that, and I'll probably have to add to it, but that's going to go on this other canopy. So I wound that other one there, but I haven't finished winding it yet. So plan of action is to continue winding the coil from this end in series with that end where I've solder tagged it, you know, and bring it and widen it out slightly and terminate it on this end so I can utilize the full coil, right? So I can put some copper solder tag tape on this end, and I want to wind that coil a little bit wider and do a test to experiment with that. So that is my next plan of action. In the meantime, I've nearly finished printing all the segments for the anti-clockwise part of the rotor. That's the back side. That's where the segments are facing the back. They're actually effectively anti-clockwise on that side, and this is on this side it's clockwise, so you get the idea. So I've printed 4 of them, and I'm just printing the other 2 right now. The other 4 are in this box. So there's the anti-clockwise ones, and they stink a bit of acetone still. I'm letting them dry out slowly because I've got to put the magnets in them yet. So I've got 2 more of these to do, which I'm printing now, and then I can populate these with the magnets from the other side, and then we can see what improvement that makes. So yeah, I just wanted to bring you up to speed on what's going on at the moment. And as I say, I've got my work cut out because I'm trying to save as much of that wire from them old canopies as I can, because there's a lot of wire. It costs me a lot of money. So I mean, I've got this other canopy. This is the 2 one. I think this was this is the twin rotor system, and there's a lot of wire on there as well. I've still got some wire on the main spool, but yeah, these are, at some point if I get desperate, I'll just take this wire off as well. But obviously at the moment there's no point, because I can go back to a 2 rotor system if I want to try that coil on the 2 rotor system, so I might leave it intact for now. It's still got the capacitor on it as well. So yeah, at some point I'll probably recycle that as well. As I say, I've still got some brand new wire on here, but I'm just trying to, all this experimentation, it costs money, and I'm trying to save money right now. So yeah, that's where we are. And this canopy was for the 1 rotor system. I debated about recycling that, and I thought, nah, there won't be enough wire on there, so I'll just leave that for now. And yeah, got a lot of plastic. I'm just trying to save money these days. I took the shielding off my old canopy when I took the wire off it, so I'm going to recycle all this nanocrystalline. It's good stuff. Anyway, that's just all there is for now. I just wanted to let you know what's happening at the moment, and I'm having some really good results. And the new rotor is much better. It's much better in balance. It's less warped. Let me just turn it and show you what I mean. You can see it's much better. It's not got that horrible kink like the other one. It's not perfect, obviously, but it's not horribly warped like that other one is. I mean, the one I took off it, and the old segments are all here, right? You can see how that one got pretty messed up down in that corner there, and that caused this wall, the inner wall, to shrink. You can see the gap there. There's a gap right there where the segment doesn't meet up with the wall because it's collapsed inwards a bit. That threw the whole thing out of balance, you see. And that's why I wanted to make a new rotor. Also, if you look on the back side, you'll notice it's got a dome shape to it, slightly domed. So it was kind of buckling a bit. Yeah, that's why I decided. And if you look at the side of it, you can see it's got a step. This is thick there, and it gets narrower. You can see it's got a slope on it because it was warped, and that was affecting the balance of everything. It was just way out. Whereas the new one, if I get the angle right, the grey one doesn't have that horrible step like the pink one does. There's maybe a little bit there, but it's not bad. This one was just a disaster. Yeah, really badly. You can see how bad it is. So yeah, I used too much acetone on that. So anyway, that's it for now. I'll keep you posted, and it's probably a few days because I've got to wind some more coils as well. And yeah. Right, see you later. I'll keep you updated. Bye for now.